When wiring an above-ground pool, several critical electrical requirements must be met to ensure safety and code compliance. Let's address the key considerations for your specific scenario, where the filter and heater are located a minimum of 20 feet from the pool wall. Firstly, despite the distance between the filter and heater and the pool, certain requirements still apply. One of them is the convenience receptacle. A convenience receptacle is still required within 20 feet of the pool edge. This receptacle is intended for plugging in pool maintenance equipment. Secondly, bonding. A bonding wire, typically number 8 American wire gauge solid copper, must connect the filter or heater electrical panel to a metal fitting on the pool wall. This ensures that all exposed metal components around the pool, including the pump and heater, are electrically connected and of the same potential. Regarding additional considerations, you may need to use longer electrical conduit and wire to accommodate the distance between the equipment and the pool. Ensure that the conduit is properly supported and protected from damage. Now let's address the second issue regarding the plastic covers and the support struts. The plastic covers are typically used to prevent dirt and debris from accumulating inside the hollow support struts. They can be installed after the electrical installation is complete, but before the footers are poured. Concerning bonding struts, the bonding wire from the filter or heater electrical panel to the pool wall should suffice to bond all metal components of the pool, including the support struts. The bolted connections between the components should provide sufficient electrical continuity. However, if the struts are not securely bolted together, or if there is any concern about their bonding, you could consider adding an additional bonding wire that runs around the perimeter of the pool and connects to each strut. For additional notes, always consult the local electrical code for any specific requirements or variations. Use only approved electrical components and materials. It is highly recommended to hire a licensed and qualified electrician to complete the installation and obtain the necessary permits. Now, let's delve deeper into each of these aspects to provide a comprehensive understanding. Starting with the convenience receptacle, the National Electrical Code, NEC, mandates the installation of a ground fault circuit interrupter, GFCI, protected receptacle within a certain distance of the pool's edge. This is primarily for safety. The intention is to provide a readily accessible power source for pool maintenance equipment, such as vacuums and lights, without requiring the use of extension cords that could pose a shock hazard. The 20-foot requirement is a maximum distance. Placing the receptacle closer is perfectly acceptable and can be more convenient. The receptacle must be a single receptacle or a duplex receptacle. It should be weather resistant if installed outdoors. Consider the placement carefully to ensure it is not susceptible to flooding or other environmental hazards. Regarding bonding, bonding is a critical safety measure that aims to eliminate voltage gradients in the area surrounding the pool. Voltage gradients occur when different metal objects are at different electrical potentials, creating a risk of electric shock if a person comes into contact with two such objects simultaneously. The bonding wire, typically number 8 American wire gauge solid copper, connects all metal parts of the pool structure, as well as any metal equipment associated with the pool, such as the pump, filter, heater, and any metal conduit. This creates an equipotential plane, ensuring that all metal objects are at the same electrical potential. The bonding wire must be continuous and unbroken. It should be connected to each metal object using approved bonding connectors. These connectors are designed to provide a secure and corrosion-resistant connection. The bonding wire should be run in a manner that minimizes the possibility of damage. It should be buried at a sufficient depth or otherwise protected from physical damage. The specific requirements for bonding are outlined in Article 680.26 of the National Electrical Code. This section provides detailed instructions on which metal parts must be bonded and how the bonding connection should be made. It is essential to consult this section of the code to ensure that the bonding is performed correctly. With respect to the electrical conduit and wire, selecting the appropriate electrical conduit and wire for the pool installation is crucial for safety and compliance. The conduit must be suitable for the environment in which it will be installed. For example, if the conduit will be buried underground, it must be listed for direct burial. Common types of conduit used for pool installations include rigid polyvinyl chloride (PVC) and rigid metal conduit (RMC). PVC conduit is lightweight and corrosion resistant, making it a popular choice for underground installations. RMC is more durable and provides better protection against physical damage. The wire must be sized appropriately for the load it will be carrying. The size of the wire is determined by the amperage of the equipment it will be supplying, as well as the distance the wire will be run. The longer the wire, the larger the size required to prevent voltage drop. Voltage drop occurs when the voltage at the equipment is lower than the voltage at the source due to the resistance of the wire. This can cause the equipment to operate inefficiently or even damage it. The wire must also be suitable for wet locations. This means that it must be insulated with a material that is resistant to moisture. Common types of wire used for pool installations include THHN and THWN. THHN wire is suitable for dry locations, while THWN wire is suitable for wet locations. It is important to consult the National Electrical Code and local electrical codes to determine the specific requirements for conduit and wire in your area. Regarding the plastic covers on support struts, the plastic covers and the support struts serve primarily to prevent debris from accumulating inside the struts. While they are not directly related to electrical safety, the proper installation is important for maintaining the structural integrity of the pool. The covers should be installed after the electrical bonding is complete to avoid interfering with the bonding connections. The cover should be securely attached to the struts to prevent them from coming loose and allowing debris to enter. Regarding bonding struts, the bonding of the support struts is an important aspect of ensuring electrical safety around the pool. While the bolted connections between the struts may provide some degree of electrical continuity, it is important to verify that the connections are reliable and corrosion resistant. If there is any doubt about the adequacy of the bolted connections, it is recommended to add an additional bonding wire that runs around the perimeter of the pool and connects to each strut. This will provide a more positive and reliable bond. The bonding wire should be connected to each strut using approved bonding connectors. These connectors should be installed in a manner that ensures a secure and corrosion-resistant connection. If the struts are made of a material that is not easily bonded, such as painted steel, it may be necessary to remove the paint or coating to ensure a good electrical connection. This can be done using a wire brush or other abrasive tool. Additional considerations include consulting local electrical codes. Local electrical codes may have specific requirements or variations that differ from the National Electrical Code. It is important to consult these codes to ensure that the pool installation complies with all applicable regulations. Hiring a licensed electrician is recommended because pool electrical installations can be complex and potentially hazardous. It is recommended to hire a licensed and qualified electrician to perform the installation. A licensed electrician will be familiar with the National Electrical Code and local electrical codes and will be able to ensure that the installation is performed safely and correctly. Furthermore, obtaining necessary permits is important because in most jurisdictions a permit is required for electrical work. Be sure to obtain the necessary permits before beginning the installation. This will help to ensure that the installation is inspected and approved by the local authorities. Other considerations include proper grounding because grounding is a critical safety measure that helps to protect against electric shock. The grounding system should be installed in accordance with the National Electrical Code. Also, ground fault circuit interrupters (GFCI) provide protection against electric shock by detecting ground faults and interrupting the circuit. Ground fault circuit interrupters are required for all receptacles and electrical equipment located near the pool. Furthermore, surge protection safeguards electrical equipment from damage caused by voltage surges. It is recommended to install a surge protector on the electrical panel that supplies power to the pool equipment. Also, regular inspections of the electrical equipment are important to ensure that it is in good working order. Look for signs of damage, such as cracked or frayed wires, and replace any damaged component immediately. Pool electrical safety is paramount. By adhering to these guidelines and consulting with qualified professionals, you can ensure a safe and enjoyable pool experience. Now let's talk about the National Electrical Code Article 680 in more detail. Article 680 of the National Electrical Code, NEC, covers the requirements for electrical installations in and around swimming pools, spas, hot tubs, and similar installations. This article is essential for ensuring electrical safety and preventing hazards such as electric shock. Article 680 provides specific guidelines for grounding and bonding, wiring methods, and the location of electrical equipment. Grounding and bonding. According to 680.26, bonding is the permanent joining of metallic parts to form an electrically conductive path that ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. Bonding is a critical safety measure that helps to equalize the electrical potential between different metal parts, reducing the risk of electric shock. Article 680.26 outlines the specific requirements for bonding various metal components associated with pools, spas, and hot tubs. This includes bonding all metal parts of the pool structure, such as the reinforcing steel in concrete pools or the metal walls of above-ground pools. It also includes bonding metal fittings, such as ladders, handrails, and diving boards. Equipment such as pumps, filters, heaters, and other electrical devices must also be bonded. A solid copper conductor of at least number 8 American wire gauge is typically used for bonding. The bonding conductor must be connected to each metal part using approved bonding connectors. These connectors must be suitable for the environment in which they are installed and must provide a reliable electrical connection. Grounding is the connection of electrical equipment to the earth, providing a path for fault current to flow back to the source. Grounding helps to protect against electric shock by providing a low impedance path for fault current, which causes the overcurrent protective device, such as a circuit breaker or fuse, to trip and energize the circuit. Article 680.21 specifies the requirements for grounding electrical equipment associated with pools, spas, and hot tubs. This includes grounding the metal enclosures of pumps, filters, heaters, and other electrical devices. It also includes grounding the metal conduit and wiring systems that supply power to these devices. A grounding electrode system must be installed to provide a connection to the earth. This system typically consists of one or more grounding electrodes, such as ground rods or ground plates, that are buried in the earth. The grounding electrode system must be connected to the electrical service panel and to the metal parts of the pool structure and equipment. Now let's discuss wiring methods based on 680.25. Article 680.25 outlines the requirements for wiring methods used in and around pools, spas, and hot tubs. The wiring methods must be suitable for the environment in which they are installed and must provide adequate protection against physical damage and corrosion. Underground wiring must be installed in rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, or liquid tight flexible metal conduit. A conduit must be buried at a sufficient depth to protect it from physical damage. Wiring above ground must be installed in rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, electrical metallic tubing, or liquid tight flexible metal conduit. The conduit must be securely supported and protected from physical damage. Flexible cords are permitted for connecting equipment such as pumps and heaters, but they must be of the extra hard usage type and must be protected from physical damage. Receptacles in 680.22. Article 680.22 specifies the requirements for the location of receptacles in and around pools, spas, and hot tubs. Receptacles must be located at least 6 feet from the inside wall of the pool, spa, or hot tub, unless they are ground fault circuit interrupter protected. Receptacles that are located within 20 feet of the inside wall of the pool, spa, or hot tub must be ground fault circuit interrupter protected. Receptacles that supply power to pool equipment, such as pumps and heaters, must be ground fault circuit interrupter protected. Lighting according to 680.23, Article 680.23 outlines the requirements for lighting in and around pools, spas, and hot tubs. Lighting fixtures must be located at least 12 feet above the maximum water level of the pool, spa, or hot tub, unless they are specifically designed for underwater use. Underwater lighting fixtures must be listed for underwater use and must be installed in accordance with the manufacturer's instructions. Underwater lighting fixtures must be supplied by a ground fault circuit interrupter protected circuit. Equipment location as described in 680.12. Article 680.12 specifies the requirements for the location of electrical equipment in and around pools, spas, and hot tubs. Electrical equipment must be located at least 5 feet from the inside wall of the pool, spa, or hot tub, unless it is separated from the pool, spa, or hot tub by a permanent barrier. Electrical equipment that is located within 5 feet of the inside wall of the pool, spa, or hot tub must be ground fault circuit interrupter protected. Some additional safety precautions include ground fault circuit interrupters, which provide protection against electric shock by detecting ground faults and interrupting the circuit. Ground fault circuit interrupters are required for all receptacles and electrical equipment located near pools, spas, and hot tubs. Regular inspections of the electrical equipment are important to ensure that it is in good working order. Look for signs of damage, such as cracked or frayed wires, and replace any damaged components immediately. Swimming pool electrical safety is paramount. By adhering to the guidelines outlined in Article 680 of the National Electrical Code and consulting with qualified professionals, you can ensure a safe and enjoyable pool, spa, or hot tub experience. Now, let's cover common mistakes to avoid. One of them would be inadequate bonding. Neglecting to properly bond all metal parts of the pool structure and equipment can create a shock hazard. Another mistake is improper grounding. Failing to ground electrical equipment properly can prevent fault current from flowing back to the source, increasing the risk of electric shock. Another mistake is using the wrong wiring methods. Using wiring methods that are not suitable for the environment can lead to corrosion and electrical failures. Placing receptacles too close to the pool is also a potential mistake. Placing receptacles too close to the pool can increase the risk of electric shock. Another mistake is improper lighting. Using lighting fixtures that are not designed for underwater use or that are not properly installed can create a shock hazard. Another mistake to avoid is neglecting ground fault circuit interrupters. Failing to install ground fault circuit interrupters can leave people vulnerable to electric shock. Not getting permits is also another mistake. Failing to obtain the necessary permits for electrical work can result in fines and delays. Not getting an inspection is also another mistake. Failing to have the electrical work inspected by a qualified inspector can compromise safety. Ignoring local codes is also a mistake because failing to follow local electrical codes can result in violations and safety hazards. Also, another common mistake is DIY without expertise. Attempting to do electrical work yourself without the proper training and experience can be dangerous. By avoiding these common mistakes and following the guidelines outlined in Article 680 of the National Electrical Code, you can ensure a safe and code-compliant pool, spa, or hot tub electrical installation. Always consult with a qualified electrician to ensure that the work is performed correctly and safely.